gentlemen, while I'm getting attendance, you should be taking everything off of your desk except for your periodic table, your solubility chart, something to write with, and your calculator. All right, ladies and gentlemen, questions before today's quiz? Okay, let's get to it then. When you're done with the quiz, bring it up, set it on my desk. After the quiz, I will eventually put up the R values. The 4 values that we were talking about yesterday at the end of the hour. Those need to be copied and put onto your periodic table because on a test I will not give them to you and you will need them to calculate problems. When you put them on there, please make sure you put the units with them because that is the reason for the 4 different values is because there are 4 different units of pressure. So if you don't know which unit to use or which one to use, you will have trouble working the problems. So I will go over what you need to do on the quiz in just a second, ladies and gentlemen. Just let me get them handed out first. All right, take a look at the front page, ladies and gentlemen. Now, it says to tell what happens to each of the 4 variables, but you do not have to tell me what happens to number of moles on the first page. Okay? But please realize that each one asks you about a different gas law. Now, in a gas law, there is either a direct or an inverse relationship. Now, the 2 variables that are in that relationship, ladies and gentlemen, you get to pick how one of them moves. And you can tell me it increases or it decreases. I don't care which. What you're graded on is if the second one matches correctly to the first one. So if there is a gas law where, let's say, volume and amount of gas are changing, we know that if volume goes up, amount of gas goes up. Or volume could go down because amount of gas goes down. You need to get both of those correct. I don't care which one you tell me. You can tell me they're both going up or they're both going down. Or if it is an inverse relationship, you can tell me which one is going up and which one is going down. But you either get them both correct or you get neither correct. Okay? And then you tell me what is happening to the third one in each case as well. All right? On the back side, ladies and gentlemen, are the actual problems. The gas laws are up at the top. You will notice there is no Avogadro's law there. Why? You don't need it. So each of those 3 problems works with one of those 3 gas laws at the top. Or you could choose to use combined gas laws if you can use it correctly. Showing me the setup is worth a point. Converting correctly into Kelvin is worth a point. And your final answer is worth 2 points, 1 for the correct number, 1 for the correct sig figs and units. If you have questions during the test, raise your hand, call me over, and I will try to answer. Yes. Okay? For the first page, you can use I, C, and D. You can use arrows up, down, and straight across. Or you can write out the terms. Is that the question? Okay. Sure. You can do arrows.
I have a question. These small is direct relationships with vaccine. This one's close to.
If something is a direct relationship, you should tell me that two of them are moving in the same direction. I don't care what.
So I don't care
What direction?
So they both are doing
Just you need correct.
Okay.
Thank you. Just leave it there. Thank you.
Thank you.
All right, ladies and gentlemen, take out your periodic tables and, well, not your periodic tables. Take out your computers, get logged in. Hopefully you have these numbers written on your periodic table because, again, you are going to need them, and I will not give them to you on a test. So you should have these written down, ladies and gentlemen. All right. All right. So up at the board on the top, ladies and gentlemen, is what is called ideal gas law. Ideal gas law says that we could change every variable in a gas. And we always have something to compare back to. We always can compare back to what are called standard conditions. Standard temperature, standard pressure, standard volume, standard amount of gas. Now, standard volume and an amount of gas are really just a ratio between volume and moles. Because if pressure and temperature are held constant, there is a relationship between the number of moles and the volume of gas it takes up, and that's what we showed you yesterday. I don't care what volume or what number of moles you have. If you take the volume of that gas divided by the number of moles, you will get the number 22.4 over 1. So in our formula, the N and the V also become constant. That means we can find what are called 4 true R values. Now, the reason there are 4 of them, because again, it sounds like I'm saying 2 different things. We have a definite constant, but there are 4 of them. The reason there are 4 of them is because we have 4 different units of pressure. And actually, in the world, ladies and gentlemen, there are more than 4 units of pressure. Meaning, on your test, when I give you a different unit of pressure than these 4, you are going to have to use it to calculate the R value. Now, if you'll notice in every one of these formulas, everything except the value of P stays exactly the same. V in every one of these is 22.4. N in every one of these is 1 mole. And T in every one of these is 273. Meaning, if I give you a different unit of pressure, that is the only thing you need to change. You put in the different unit of pressure here, and then you calculate it. And that will give you an R value, ladies and gentlemen. And I will guarantee you, I'm going to ask you to do that on your test. Questions? Now again, we have a formula for you. Ideal gas law is PV equals nRT. The reason they set it up that way and not PV over NT equals R is because we already got it on one line for you. All of our other formulas, we end up putting them into one line. So this one, we're going to put it into one line for you. You should be able to substitute in 3 other things besides an R value, and you should be able to solve your problem. Meaning if you are given pressure, volume, and temp, you can figure out how many moles of gas there were. Meaning if you are given pressure, volume, and amount of gas, you should be able to figure out what temperature it's at. Meaning if you are given pressure, amount of gas, and temp, you should be able to figure out the volume. And then finally, meaning that if you're given volume, amount of gas, and temperature, you should be able to figure out the pressure. Denaya, did you have a question? Okay. All right. So here's how the problems work, ladies and gentlemen. What is the pressure in atmospheres of a 0.108 mole sample of helium gas at a temperature of 20 degrees Celsius and the volume is 0.505 liters? So, temperature, volume, what is this? N, amount of gas. You are given 3, you can find the 4th. Now, it tells you what unit they want pressure in, correct? They want it in atmospheres. That is going to determine which of the 4 R values we use. Okay? Now, again, when we plug things into this formula, we have to be careful of temperature. Temperature must be in what unit? Kelvin. We can put any unit of pressure in. Number of moles, that is the only unit it can be in, is moles. Now, I could have given you the grams of this gas. You could convert grams into moles using what we learned in the last unit. The one thing to be careful of is the other unit that matters here is the volume unit. No. Unit. Volume unit has to be in liters, not milliliters, not cubic centimeters. And the reason for that is our R value here. All of these are in liters. So your volume in ideal gas law always has to be in liters. It cannot be in milliliters. You would have to convert it. Okay? So now we convert our temperature into Kelvin, 293 Kelvin. We plug everything into our formula. We don't know what the pressure is. Here is our volume. N value is 0.108 moles. This is the R value we are going to use because of the fact that it has ATM in it, and that is what we want our pressure to ultimately be in. If they give you a pressure, you have to pick the R value that is for that unit of pressure. Okay? Since they're asking you to go into ATMs, we pick the R value that is going to give us ATMs. Why? Every other one of these units is going to cancel out. Every other one. So now we arrange it so that we are solving for P alone. It is the only thing on one side of the equation. P equals 1.08 moles times 0.0821 liters times atmospheres over mole times Kelvin. That is a huge unit, ladies and gentlemen. Yes. But most of that unit is going to cancel out. Times 293 Kelvin. Okay? By the way, there is no predicting here. There is no predicting what pressure is going to do. Is it going to be up or down? Why? Because we don't actually have a number we are comparing it to. That number is kind of hidden in here. That number is actually 1 atmosphere. Okay? But because we are changing 3 things, you would drive yourself nuts trying to figure out what would happen to pressure. Don't worry about it. Just do the math. Okay? Now again, you go to put this into your calculator. 1.08 times 0.0821 times 293. No parentheses needed because there's only one number on the bottom. Dividing by 0.505. Now, take a look at your units here for a second. Liters here and liters cancel out. Moles cancels out with moles here because this is on the bottom of this fraction. This is actually liters times ATM over mole times Kelvin. So this mole cancels out with this one. This Kelvin cancels out with this one. The only unit you're left with, ladies and gentlemen, in the end is ATM, which is exactly what you want to be in because you are trying to find a pressure.
So you copy all the standard conditions now?
What?
You just copy all the standard conditions.
You only need to copy the R value down. When you say copy all the standard conditions down, I don't know what you mean, Denaya.
You said copy all the R value down?
The instructions were on this slide to copy down the R values. That is those four numbers there. The R equals. That was the instructions. Okay? That was the instructions. When we're done, ladies and gentlemen, we get a pressure of 5.14 atmospheres when we do this math. That would be the pressure of the gas under these conditions. Okay? That would be the pressure of the gas under these conditions. Questions? Yes, no, maybe so. So now we can handle a problem if there are only two variables. We can handle a problem if there are three variables. And now, ladies and gentlemen, we can handle a problem if there are four variables. If they give us three of the four, we can find the fourth. But the way we're doing it is we are comparing it back to what are called standard conditions. Standard conditions never change. Standard condition is always standard pressure, standard temperature. Standard temperature is always 273. Standard volume is always 22.4 liters. Standard number of moles is always 1. Those give us the R value. Natalie, did I do something wrong mathematically? Because you've got a look on your face like something isn't quite working out.
Oh, well, you put 14, but I got 51.4.
You got 51.4. Did anybody else get that? Did you put the 0 in front of the 0.0821?
Yeah.
And you use 0.108?
Yeah, I'll do it.
Well, just double check and make sure you have the numbers correct. It is very possible that I have a typo in it.
I got the 51.4.
You got the 51.4? Anybody else? All right, I'm going to trust you guys. Don't mess me up on this. Thank you, Natalie. Okay, there you go. Questions? How many grams of nitrogen dioxide are present in a sample that occupies 975 milliliters under a pressure of 75.6 kPa and a temperature of 45.0 degrees Celsius? By the way, I should have pointed this out. How many sig figs? Don't everybody shout it out all at once. You should be getting sick of me asking this, but you should be able to tell me. How many sig figs here? 3.
3.
So how many in your answer?
3.
Only 3. It's that easy. That's all I'm expecting you to do. Look at every number that you are given in the question. The smallest number of sig figs in that question is how many are in your final answer. All right, so here we go, ladies and gentlemen. Now, first of all, in any of these gas laws, do we use grams? No. What's the closest one to that, though? Oh. What can we convert out of the 4 pressure variables easily into grams? Think last unit, ladies and gentlemen. No. You've got what variables here? What variables do you have here? What do you have numbers for? For which of the variables in our formula? Okay, kPa, what is that giving us? Pressure. So you've got a pressure. What is 975 milliliters? A volume. Ladies and gentlemen, you're going to start getting these units correct. You're making life so much harder on yourself. Volume. Pressure. What's missing? Amount of gas. What unit is amount of gas in? Have I ever given you any way of going from moles to grams? No?
Yeah.
No?
Yes.
The entire last unit was that. Yeah, you got to use what you learned in the last unit. If we get into moles, we can get into grams. Oh my gosh, I just thought of something. You're going to have to use what to get from moles to grams? Oh my God, you guys are going to die on the test in a week and a half. No, thank you, because I'm glad you learned something, and then as soon as we're done with it, you throw it away and forget about it. How do we get from moles to grams? What? Formula mass? Oh my God, we're going to have to do a formula for a compound? Yeah, that shouldn't be that hard for you. That should not be hard for you. What's our compound? Good. Give me the formula for nitrogen dioxide. NO2. Good. Why do you think I gave you the blue sheet, the hash sheet, the blue sheet, this unit, ladies and gentlemen? You need to do formulas again. PV equals nRT. That is what we are going to use, ladies and gentlemen. Okay? We're going to convert our temperature into Kelvin. 45 degrees Celsius, 273, 318 Kelvin. I also need to make one more conversion before I can begin the problem. What is it? Milliliters to liters. I need to convert 975 milliliters into liters. Do you need to show me either one of those two conversions? Absolutely not. But you need to do them.
Do you have to change it from milliliters to liters?
You have to. That is not a negotiable. The reason for it is the unit here has liters in it. The R value has liters in it. So your volume in your problem, if you're going to work it with this, has to have liters in it. Has to. No doubt about it. It has to. Okay? So now we're going to plug in our numbers. We got a pressure, 75.6 kPa. We've got a volume, 0.975 liters. We do not have the value of N. Moles is what we are solving for and then going to convert it into grams. We have the R value of 8.31. Why this R value? Why not the 0.0821 we used last time? They're all standard ones. Why that R value here? Linda, why that R value? Not sure. Langdon?
Because it's kPa, not ATM.
Our unit is kPa. Our unit of pressure is kPa. Our R value needs to match that unit. So we pick the unit, the R value that has the same unit that our pressure does. In the last one, we used 0.0821 because our pressure wanted to be in atmospheres. That is the R value for atmospheres. Your R value gets determined by what unit your pressure is. Our temperature, 318. Now, again, we are going to solve this by getting N alone on one side. To do that, what do I do to this side of the equation? Divided by the 8.31 and also the temperature. So when we do that, ladies and gentlemen, we get N is equal to 75.6 kPa on top times 9.975 liters over 8.31 liters times kPa over mole times Kelvin times 318 Kelvin. Guess what? Two numbers on the bottom. What do you got to do when you divide? Put them in parentheses. Put them in parentheses, ladies and gentlemen. So we are going to take and we are going to multiply the two numbers on the top together. We're going to hit the divide by button on our calculator. We are going to put one parenthesis and put 8.31 times 318. Close your parenthesis. Now we'll see if I did my math right on this one. What do you get? 0.027. Anybody else? So 2789. By the way, while I am not grading that number, ladies and gentlemen, I would carry at least 3 sig figs there. At least 3, not less. Why? Because now what do I do with that 0.0279 moles? I go to grams. I'm going to go to grams. So I'm going to take that number in moles and I'm going to go to grams. Now, how do I get this number up here? 46.0758. Formula mass of nitrogen dioxide. 1 nitrogen, 14.007. 2 oxygens, 15.999. Add them together, 46.0758. Again, moles and moles cancel. I am left with grams. Grams of NO2 should have come up around 1.28 if my math is correct there. Questions? Determine the temperature in degrees Celsius required for 6.51 grams of sulfur trichloride gas to fill a balloon to 1.20 liters under a pressure of 0.988 atmospheres. Here's the good news, ladies and gentlemen. We no longer have to worry about P1s and V1s and P2s and V2s. You just have to figure out what your numbers represent. 1.20 liters. What is this, Adelaide? What is this representing, 1.20 liters? Volume. 0.998 atmospheres. What is that representing, Madison? Pressure. 6.51 grams. What is that representing, Claire? Mass. But nowhere in our formula, PV equals nRT, is mass. What's the closest thing? Moles. Can we convert 6.51 grams into moles? How? What do we need? We need the formula mass. So we need the formula mass for SCl3, sulfur trichloride. So, sulfur, 32.06, plus 3 chlorines at 35.453, giving us a mass of 138.41. Now, in this problem, grams is on the bottom, moles is on the top, so that we can get into moles. Okay? Now we can plug this in for N. So now I've got a volume, I've got a pressure, I've got N, R, you should be able to find it. It's a known value, doesn't change, meaning we could solve for T when we put everything in. Now again, I'm back to using 0.0821. Why? Why am I using 0.0821 for an R value, Daniel? Why am I choosing? There are 4 R values. 8.31, 62.4, 0.0821. What's my last one? 1.21, thank you. Why am I choosing to use 0.0821, Daniel? Why did I pick that one out of the 4? They all have moles in them, though. How do we choose an R value? What is it based on? What? The unit of pressure. Our pressure is in ATMs, so our R value has to be the one for ATMs. We plug it in here. You now have an equation where you only have one variable, ladies and gentlemen. You could solve that. First, we were solving it when we had one variable out of 4. Then we were solving it when we had one variable out of 6. Now you are solving it when you have one variable out of 5 things. So again, we get T alone. To get T alone, we're going to divide both sides by 0.0470 moles times 0.821 ATM times liter over mole times Kelvin. That gives us this. Again, 2 numbers on the bottom. Make sure you put them in parentheses when you divide by them and multiply them together. Somebody tell me what we get for a temperature. What do we get for T? Thank you. Okay, I got 307.3. In Kelvin. Why? Because gas laws always give us temperature in Kelvin. How do I get it back to degrees Celsius?
Minus 273.
Minus 273, final answer 34.3. 34.3. Questions, ladies and gentlemen? Those are your 4 R values, ladies and gentlemen. You don't have them written down, you're going to struggle doing these problems because you're going to have to look them up every time. Or worse, you're going to have to calculate them on the test. Because I'm not giving them to you. I will give you formulas. I will not give you the R values. I will not give you the conversion from milliliters to liters. I will not give you the conversion from temperature in Celsius to temperature in Kelvin or temperature in Kelvin to temperature in Celsius. You need to write those down if you cannot remember them. Good luck remembering those. I've been doing this for 27 years. I just couldn't think of the 1.21 a moment ago. Isn't always easy. Questions? Come up, grab a sheet of scratch paper, ladies and gentlemen. I want to know what the R value would be for standard unit of pressure of 29.58 inches of mercury. I guarantee, you will get a question just like this on your test. Guarantee. Give you a hint. You are using PV equals nRT to solve this, ladies and gentlemen. And what are you solving for? What is it asking you to calculate?
The R value.
The R. So you're solving for R. Wow. Holy cow, that might have been the nicest thing I've ever heard you say to Claire. Go away.
Mr. Brown. Was that supposed to say MMHG?
No, it's not. Nope. Because then it would be 760. It says IN, inches of mercury. INHG, it's a different unit of pressure. It is not one of the four that I have given you. So you should be able to use this to calculate an R value. All right, Ethan, tell me what formula we are going to use. Ethan, tell me what we are solving for. What is the only formula I have given you that involves R? We were just working a bunch of problems with it. Every example that I gave you today, we used it to solve the problem. What was that formula, Ethan? Go into your notes under ideal gas laws, Ethan. Tell me what the formula is. Tell me what the formula is, Ethan. Thank you. PV equals nRT. That is the formula that we are using. Okay? So we are going to use the formula PV equals nRT. Parker, what are we solving for in this formula? So this is the one that we are going to leave blank, which means we need to fill in P, V, N, and T. All right, Jaden, give me P.
9.58.
Inches of mercury. Good. All right, Giselle, give me V.
22.4.
Okay. Jalen, give me N. Okay, Jalen, if we're using 22.4 for liters, in the last unit, not 100, what number of moles? What is it? Thank you. 1 mole. 1.00 mole. Now again, Parker told us we were solving for R, so I'm going to leave R. So then finally, ladies and gentlemen, what is our T? What is the temperature here? Go ahead, Natalie.
273.
273K. So now, ladies and gentlemen, we have an equation with one variable. Let's solve for it. Going to take this side and divide it by 1.00 mole times 273 Kelvin. What I do to one side of an equation, I do to the other. So R equals what, ladies and gentlemen? I'm sorry, a little louder. 27? We're going to put it in 3 sig figs just like every other one of them up there. What's the unit? INHG times liters over mole times Kelvin. If I give you some unusual unit of pressure, ladies and gentlemen, we can find the R value for it. Why? Because 3 of these 4 numbers never change. You want to feel challenged, ladies and gentlemen? Make this 44.8. But if you do, what else do you have to change? Mole to how many? 2. Why? Because that still amounts to 22.4 over 1. What? Well, if you double the amount of gas, what happens to the volume of the gas? How much? It would double as well. There is a relationship between volume and amount of gas at STP. Okay? Good. Good. Questions? Okay. Those were the easy gas laws. Next week we get into more specialty ones. Have a great day, ladies and gentlemen. Go away. Goodbye.